Welcome to the 8th session of Basics of Remote Sensing. Here we discuss about elements of image interpretation. Myself, Anup VM, Senior Geologist, Photogeology and Remote Sensing Division, Geological Survey of India Training Institute, Hyderabad. What is image interpretation? It is a technique or process of assigning identity to an object based on scientifically proved and time tested methods through our experience and through our perception. There are two major types of remote sensing data products for our interpretation. One is as a pictorial in a hard copy, and the other one in a digital format. So there are two ways of remote sensing data interpretation: visual interpretation and digital interpretation. Visual interpretation. Visual interpretation involves detection, categorization, and identification of features. So what is exactly a detection? The image which is given on the screen, you can see it is representing our globe in some colors. What those colors are giving as a part of information. What are the different types of colors are there? What all things we can detect from that? So here comes detection. It is a process of spotting objects to separate out an object from its background surroundings. Contrast detection and boundary detection between an object contour and the surroundings is the first step to be resorted. When you are seeing an image, you can see through your knowledge, through your experience, it is representing different continents. Some of the parts of that continent, they are having different colors. Their boundaries are sharp with respect to the other color. So how you will categorize it? That is categorization, classification of objects or areas by specific criteria through a more formal process of discrimination. We are trying to categorize that image based on that color difference. We'll differentiate particular image. Identification. It is assigning proper names to the categories, essentially an act of recognition. After categorization, based on the informations we are having, we will try to identify and give proper names. So let's try to solve this image. Using your informations, try to see different locations in that particular continent, different geographical informations. You can see the blue color is indicating our ocean, and the mighty Himalaya you can see in a deeper red color, and Andes Mountains and some of the highly elevated areas you can see orange to deep red colors. So using the information which we are having, we are trying to interpret that data. So you can categorize that after detecting based on our spontaneous recognition using our logical inferences, and we finalize the data, its interpretation through ground truth verification. So this is how we analyze and interpret a particular image. This technique is used for our visual interpretation various data. As the technology developed, the aerial photographs were used earlier days using stereoscope. We try to interpret our data. Then the hard copy imageries, satellite imageries getting popular. The informations contained in a satellite image is interpreted. in order to prepare various maps, geology map, geomorphological map, landform maps, etc. Arrival of computer systems, digital data processing started. Using various softwares, we are processing a digital imagery in order to improve our interpretation. So, our image interpretation involves both visual as well as digital interpretation techniques. In order to make our interpretation easier, there are certain elements of visual image interpretation techniques we use. These are tone or color, texture, pattern, shape, size, shadow, association, and convergence of variance evidences which we are having with us. What is tone or hue or a color? Tone refers to the relative brightness or color of the object on a particular image. It is always explained in the form of a relative sense. It depends upon terrain characteristics as well as image acquisition factors. It depends upon the nature of the surface in the angle of observation and illumination. Mostly, the smooth surface behaves like specular reflectors, and these features may appear bright or dark in an imagery. A rough surface behave this as a diffuse reflectors with medium gray tones. Let's see this aerial photograph. Definitely, you will identify some features. You can easily identify the Great Pyramids of Egypt based on its shape and your previous knowledge about that megastructures. But as an image analyst using the key elements of interpretation, I will try to see this imagery in different shades of gray. You can see the variation of gray in this particular image from darker to brighter. Some of the features showing as a rough surface in the form of building, trees, and when you are seeing the brighter pixels or brighter shades in the form of sand or a smooth surface. So, if we are getting a particular image, we try to observe that in the different shades of gray as the amount of light reflected from the surface. It may be due to different reasons. You can see various tonal contrast in this imagery. A satellite image with various tonal contrast that may be due to the moisture content in that area, the surface reflectance of different materials on that particular imagery that will be different. And if you see different shades of blue in the sea, that may be representing the sediment deposits, shallow and deep water column. Like this, as an image interpreter, you can analyze various tonal contrast from a aerial photograph as well as from a satellite image. The next key element is texture. What is texture? Texture is the frequency of tonal change on an image and produced by an aggregation of unit features that may be too small to be discerned individually on the image. What it says? When you try to see an image, you will be identifying various tonal changes that may be with a high frequency or that may be in a low frequency. That may be a small or in a large area. It reflects in the form of different shape, size or patterns. It is a combination of all these factors. It overall determines visual smoothness or coarseness of image features. A texture is the apparent smoothness or roughness on an imagery. We explain or describe them in the form of fine, medium, coarse, mottled, blocky, rough, or smooth. Let's see textures. Here we can see a fine texture, a medium texture, a rough texture, and a mottled texture which looks like the overturned leaf. If you try to see the backside of a leaf, you will see the ribs. Like that, some features you can see. Such kind of textures are mottled textures. And you can see the blocky and patchy textures. So this will help us to differentiate different lithologies, different surface on our earth. Next come pattern. Pattern relates to the spatial arrangement of objects. It refers to distinctive arrangement of features. Patterns may be man-made or natural. Patterns in urban settlement as well as in a banded pattern in a sedimentary rock, flow pattern in a basalt are some of the examples of various patterns. Here in this image, you can see the flow pattern in a basalt, an urban pattern of various building road network in an urban area. Here we can see the agricultural pattern in different climatic conditions. You can see here the glacier or snow cover pattern. You can see here the urban pattern within the vegetation cover. You can see the sedimentary pattern, can see the sand dune pattern, and interestingly the cultivation pattern in deep deserts in a circular manner. These are outcrop patterns. When we are talking about various lithological formations, we define the outcrop patterns as linear, curvilinear, irregular, banded, blocky, etc. Linear ridge may indicate a quartz reef or maybe dike. That may be mafic or felsic. Banded pattern indicate interbedded sedimentary units or metamorphic rocks. Here you can see few examples. You can identify the linear pattern of dikes, sedimentary bedded sequences. I have few questions for you. The relative brightness or color of the objects on an image. Options. Option number 1, texture. Option number 2, tone. Option number 3, shape. What is the answer? Option number 1, tone. Second question. Apparent smoothness or roughness is defined by options. Option number 1, size. Option number 2, shape. Option number 3, texture. What is the answer? Option number 3, texture. Shape. What is a shape? Shape defines the geometry of objects or the outline of a feature. It refers to general form, configuration, or outline of individual objects in an imagery. In these imageries, you can see different shapes. By the informations which we are having previously, you can identify the circular shape. Here it is showing the stadium. The right hand side you can see different shapes of building, road, and in the bottom you can see it is reflecting a particular shape of a horse race stadium. Some geological features like volcanic cones, sand dunes, or river terraces or alluvial fans, they have a particular shape. Here we can identify based on their shape volcanic craters, the lava flow from the volcanic crater, the meandering pattern of a river, as well as a sand dune shape in a desertic condition. Size. It represents the length, area or volume. Size of objects on image must be considered in the context of image scale. It can be relative size or absolute size. Relative size determined by comparing the object with familiar nearby features, whereas absolute size refers to use of aerial image to derive measurements. It is widely applicable in urban planning or mapping of cities. Relation between a size and shape. Rectangular features often indicate human influence, such as agricultural pattern or different plots. Size and shape information greatly influenced by image resolution. If we are having a very high resolution data, we can easily identify the size, shape, and dimension of a feature from a data. Knowing the scale of the image, which helps to convert feature dimensions on the image into actual dimensions. Shadow. Shadow reveal the position of the sun and can be useful in determining symmetry or asymmetry, size and shape, particularly effective in identifying buildings and other structures that only show a top view of the structure. Shadow can give an indication to the size of particular feature. Sometimes this shadow will mislead for our interpretation. Here we can see the presence of clouds in the right hand side image. Just below to that image in a particular angle you can identify some black patches. If you try to relate the shape, size of that object, that's our cloud, you can relate that shadow also. So here, as we discussed in the previous slide, we are trying to relate the size as well as shape of the object that will help us to identify the shadow. In the other image, you can see the building and their respective shadows in a particular angle. Association. Association is occurrence of certain feature in relation with other. Certain features are not directly identifiable by its appearance in an image, but could be interpreted easily according to its relationship with the surrounding features. For example, association of ship in a harbor, aircraft with runway, playground associated with school. Association refers to the distinctive spatial interrelationship between features. Schools often associated with athletic fields, large parking lots often associated with malls and buildings. Convergence of evidence. Ultimately, our interpretation cannot be drawn by just one or two key element criteria. The information should be properly screened to see if there is proper corroboration of evidence. Conclusion should be based as far as possible on convergence of various evidences related from one particular key element with the other. This is necessary to counter various limitations in the interpretation technique. Apart from this, field verification or ground truth verifications are must for a proper visual interpretation. Thank you for watching. This is the end of the current session, and the next session is on detailed visual interpretation of remote sensing data.